Welcome to this explainer. Today we are going on a seriously exciting journey. We'll start by popping the hood to see how the foundational mechanics of AI actually work, and then we're going to take that knowledge and use it to visually orchestrate your very own full-stack apps. By the end of this, you'll see exactly how the old walls between visual design and hardcore code have literally vanished.
Okay, let's dive into this. Here's our roadmap for today. First, AI mechanics, tokens and prediction. Second, controlling AI, temperature and settings. Third, the vibe coding revolution. Fourth, Ajath's parallel agent crew. And finally, designing on the infinite canvas.
Understanding how this AI engine ticks is the secret to making you a vastly better system architect for your own apps. So I want you to think about this for a second. What if you could command an entire team of AI developers to build a full-stack app just by describing your vibe? For decades, the massive wall keeping creative folks from launching software was the unforgiving syntax of traditional code. But what if that barrier was just gone? That is the ultimate payoff we're exploring today.
Section 1. AI mechanics, tokens and prediction. To actually command an AI effectively, we've got to understand how large language models read and generate text. A huge misconception is that AI runs on strict, logical grammar rules like a regular computer program. Actually, scratch that, it doesn't at all. At its core, an LLM is a giant neural network, usually built on the transformer architecture, that relies on this concept called next token prediction. Using a brilliant mechanism called self-attention, the AI reads sequences of words simultaneously, finding relationships across long distances. It basically turns reading into a massive math problem, calculating probabilities to guess the absolute most likely token to come next based on all its training data.
But wait, what exactly is a token? Well, neural networks only understand numbers, so they can't process raw text. They need a tokenizer. We have a few options here. Word-level tokenization feels intuitive to us, but it's super brittle for an AI, requiring a massive amount of memory for every tiny variation of a word. Then there's character-level tokenization, which shrinks the vocabulary way down, but the AI totally loses local semantic meaning. That brings us to subword tokenization, specifically byte pair encoding or BPE. This is the industry standard used by models like GPT. It iteratively merges frequent character pairs to build a beautifully balanced vocabulary of about 30,000 to 100,000 tokens. It keeps common words perfectly intact, but elegantly splits complex or unfamiliar words into recognizable chunks, like splitting the word unhappy into un and happy. These tokens, they are the raw fuel for our AI engine.
Section 2. Controlling AI, temperature and settings. Now, if tokens are the fuel, how do we steer? How do we tell the engine, hey, we need exact, perfectly structured code right now versus let's have a highly creative brainstorming chat? So the crucial point is the number 0, specifically setting the LLM temperature to 0. Temperature controls the sharpness of the AI's probability distribution. When you set it to 0, you trigger what's known as greedy decoding. This forces the AI to always pick the single highest probability token, bypassing any creative risks. If you're generating coding facts, resolving complex logic, or building really strict database schemas, setting that temperature to 0 is absolutely vital for reliability. But there's a fascinating caveat here. Even at absolute 0, you don't always get 100% exact, deterministic results every single time. Crazy, right? Why does that happen? It comes down to physical hardware. When the AI processes your prompt, it's using parallel thread calculations on GPUs. And due to this thing called GPU floating point non-associativity, the math operations just don't always sum up in the exact same mathematical order across different threads. Combine that with server-side concurrent batching, and you might get responses that are 95 to 99% similar instead of identically matched bits. It's a great reminder that we're dealing with incredibly complex physical networks here, not just simple calculators.
Section 3. The Vibe Coding Revolution.
So, now that we know how the engine works under the hood, it's time to get behind the wheel. We have entered a massive paradigm shift. As Google Cloud so perfectly puts it, natural language prompts allow anyone to describe their vision and deploy fully functioning web applications to production in minutes. Think about that for a second. This isn't just a minor tweak in how we build software, it is a total democratization of the software lifecycle. You don't have to be a senior engineer anymore to bring a complex digital product to life.
Just look at the contrast in cognitive load. In traditional app development, your mental energy is totally drained by learning rigid syntax rules, getting stuck in endless debugging loops, and banging your head against the keyboard resolving API configuration conflicts. But with vibe coding, your role fundamentally changes. You act as the creative director. You use natural language prompts to guide the system, and you let zero setup infrastructure handle all the boring, tedious stuff.
Section 4. Ajath's Parallel Agent Crew.
To see what this revolution looks like right now in 2026, we have to look at Ajath. It's a premier platform that turns this vibe coding concept into an absolute reality. Let's take a peek into the back-end architecture that makes it so incredibly powerful. Most AI tools fail at building full apps because they rely on a single chatbot. It writes the front end, then forgets the back end, breaks the database, and boom, you're stuck in a sequential debugging loop. And this brilliantly illustrates how Ajath destroys that bottleneck by executing up to 10 parallel agents at the exact same time.
Let me introduce you to the specific crew handling all this heavy lifting. You've got Maya 4 acting as your core orchestrator. While she's managing the big picture, Reina is building out your front-end UI, Jacob is structuring your back-end database schemas, and Matt is locking down secure authentication. And I really want to stress the word concurrently here. They are not taking turns, because they execute in parallel. Using those optimized low-temperature LLM predictions we talked about earlier, they can build complex software architectures in just a fraction of the time.
Section 5. Designing on the Infinite Canvas. So you've got all this unbelievable parallel AI power working in the background, but how do you, as the designer, actually interact with it? Well, this is where the magic truly happens for visual thinkers. The process is remarkably seamless. Step 1, you just prompt your vision using natural language, setting the vibe and your core requirements. Step 2, instead of just staring at a boring chat window full of raw code, you move straight to Ajath's real-time infinite canvas. This is where you can visually tweak layouts, adjust UI elements, and really refine the user experience exactly like you would in a high-fidelity design tool. But here's the kicker. Because of those parallel agents, your visual tweaks are instantly tied to real-time code updates on the backend. Finally, step 3, you deploy. Because Ajath uses zero setup, full-stack infrastructure, your database, hosting, and over 100 API integrations like Stripe, OpenAI, or Google Workspace, they are already configured. The whole shebang. You get a live, production-ready, shareable URL right from day one.
We started today by looking at how AI uses next token prediction and subword tokenization to read text and how temperature settings control its output. Then we saw how that foundational tech powers parallel agent crews like Maya 4, Reina, Jacob, and Matt, totally wiping out the old bottlenecks of app development. You are no longer constrained by the rigid rules of programming syntax, my friends. You are now fully equipped to be the system architect and the creative director of your very own software. So I leave you with this final thought. Now that syntax isn't a barrier, what will you build today?